A comet just erupted near the sun, and now a massive solar storm is racing to meet it on a collision course. In the next few weeks, Comet C/2025 R2 Swan will make its closest approach to Earth in recorded history, just as the sun unleashes its mightiest flare in months. This cosmic alignment is incredibly rare. We have a volatile comet, a powerful solar eruption, and a front-row seat from Earth. What happens when a solar storm meets a cosmic visitor? Let's explore this extraordinary scenario together.
First light. The outburst begins.
Comets are notoriously unpredictable, but what happened on September 26 caught everyone by surprise. Just 2 weeks after its closest pass to the Sun at a perihelion of 0.5 astronomical units, Comet Swan suddenly roared to life. Initially, it was a faint object, but amateur astronomers in Japan and Australia noticed a dramatic surge in brightness overnight. This wasn't a minor flicker. The comet's brightness leaped by a full magnitude, from 7.4 to a peak of 5.7, pushing it into naked-eye visibility under dark skies. What caused this? As the comet swung away from the Sun, intense solar heat penetrated its frozen nucleus. Pockets of sublimating cryovolatiles like frozen carbon monoxide and carbon dioxide buried for millennia reached their breaking point and exploded through the crust. This outburst ejected a massive cloud of gas and dust, dramatically expanding the comet's atmosphere, or coma, and feeding its enormous tail. According to cometary scientist Dr. Casey Liss of the Johns Hopkins Applied Physics Laboratory, such outbursts provide a rare glimpse into the primordial material from which our solar system was formed. This event signaled that Swan's inner engine was now exposed, making its next moves completely unpredictable and turning it into a prime target for skywatchers worldwide. The sudden release of energy was so significant it altered the comet's light curve, deviating sharply from all predictive models.
Anatomy of a tail.
This isn't just a faint smudge in the sky. We're talking about a structure wider than 5 full moons laid end to end, stretching over 15 million kilometers through space, and its design tells a story. Comets actually have 2 distinct tails, and Swan's outburst put both on magnificent display. The first is the dust tail. It's broad, curved, and shines a pale yellow as it reflects sunlight. It's made of heavier micron-sized particles that are pushed gently by solar radiation pressure and tend to lag behind in the comet's orbit. The second, and more dramatic, is the ion tail. This tail is a narrow, straight ribbon of electric blue, composed of ionized gas like carbon monoxide ions, or CO+, which fluoresce brightly when excited by solar ultraviolet radiation. This glowing stream is blown directly away from the Sun by the solar wind at speeds exceeding 400 kilometers per second, acting like a cosmic windsock. As noted by comet expert Carl Battams of the U.S. Naval Research Laboratory, the ion tail is a perfect natural probe of interplanetary conditions. With Swan's tail now stretching across a huge patch of sky, it has become a perfect natural laboratory, exquisitely sensitive to the solar storm that is now heading its way.
The Sun awakens.
Just as the comet was putting on its show, the Sun, which had been quiet for weeks, decided to join the party with its most powerful eruption in months. On September 28th, at 0843 Universal Time, satellites from the GEOES network detected a massive spike in X-ray emissions, jumping from a background level of 1 × 10 to the -6 to 6.4 × 10 to the -5 watts per square meter. An M6.4 class solar flare had erupted from a magnetically complex sunspot group designated Active Region 4232, then rotating into view on the Sun's southeastern limb. M-class flares are the second strongest category, and a 6.4 is a significant event powerful enough to cause radio blackouts on the sunlit side of Earth. Scientists at NOAA's Space Weather Prediction Center, like lead forecaster Dr. Alexei Pevtsov, immediately began analyzing data from the Solar Dynamics Observatory's AIA instrument at multiple wavelengths, including 131 angstroms, to assess the flare's power and, more importantly, what it threw into space. The energy release was equivalent to millions of hydrogen bombs detonating simultaneously. The timing was incredible. Just 2 days after the comet's own eruption, the Sun had fired a warning shot into the exact same quadrant of space.
Plasma on the move.
A flare is just the flash of light. The real power is in the billion-ton cloud of magnetized plasma it can hurl into space. And this one wasn't aimed at us. Within minutes of the flare, coronagraphs aboard the SOHO spacecraft, specifically the LASCO C2 and C3 instruments, confirmed that a massive coronal mass ejection, or CME, had been launched. This wasn't just a puff of smoke, it was a colossal bubble of solar material and magnetic fields, with an estimated mass of, well, about 1 trillion kilograms, racing outwards at a staggering speed between 800 and 1,000 kilometers per second. Forecasters at NOAA's Space Weather Prediction Center, using the WSA-Enlil prediction model, quickly charted its trajectory. The verdict: Earth was in the clear, but the CME was barreling directly towards the region of space now occupied by Comet Swan and its magnificent sprawling tail. Solar physicist Dr. Angelos Vorlidas, a leading expert in CME imaging, confirmed the CME's broad 90-degree angular width made an encounter highly probable. A rare and potentially violent collision was now inevitable within 48 to 72 hours.
Magnetic scissors.
So, what happens when a comet's tail, which is a magnetic structure, meets a massive magnetic cloud from the sun? Sometimes things just snap. This phenomenon is called magnetic reconnection, and it's one of the most explosive processes in the solar system. A comet's ion tail is made of plasma, held together by magnetic field lines streaming away from the sun. A CME, however, is a tangled web of powerful magnetic fields, often containing a strong southward-pointing component, known as the Bez field. If this southward Bez field, with a strength potentially exceeding 20 nanoteslas, slams into the comet's oppositely directed magnetic field, they can't merge. Instead, they collide, break apart, and explosively reconnect into a new shape. As space plasma physicist Dr. James Drake has explained, this process converts magnetic energy into kinetic energy with incredible efficiency. When this happens, the energy release can be immense, acting like a pair of magnetic scissors that cleanly severs the entire ion tail from the comet's head. This is called a disconnection event, and it can happen in a matter of minutes, leaving the old tail to drift away as a new one begins to form.
The forecaster's puzzle.
Predicting this collision is more complex than it sounds. It's like trying to predict if one puff of smoke will hit another in a hurricane. While models from NOAA's Space Weather Prediction Center, like the Enlil heliospheric model, showed the CME's main lobe sweeping through Swan's sector, CMEs expand, twist, and deform as they travel hundreds of millions of kilometers through space. Hitting a relatively small target like a comet's tail is not a guarantee. The biggest challenge for forecasters is the lack of direct measurements. Since the CME is not aimed at Earth, we won't get in-situ data from satellites like the DSCOVR spacecraft, which normally act as a warning system by sampling the solar wind a million miles upstream from us. Scientists must rely on images from spacecraft like SOHO and Stereo A to refine the CME's trajectory and predict the exact time of impact. An error of just a few degrees in the initial launch angle can result in a 10 million kilometer miss by the time it reaches the comet. The best estimates place the arrival between 48 and 72 hours after the flare. But the question remains, will it be a direct hit, a glancing blow, or a near miss?
Citizen science mobilizes.
When a cosmic event like this unfolds, the big observatories aren't the only ones watching. A global network of backyard astronomers becomes the front line. Professional telescopes have schedules booked months in advance, so they can't always drop everything to watch a single event. But citizen scientists, however, can provide continuous round-the-clock coverage. This is crucial because a tail disconnection event can be incredibly fast, unfolding in less than 2 hours. An amateur astronomer with a modest setup, like a 10-inch reflector and a modern CCD camera, could be the first person to capture the collision. Organizations like the Association of Lunar and Planetary Observers, ALPO, have entire sections dedicated to coordinating comet observations. Renowned astrophotographer Damian Peach has shown how high-resolution amateur images can rival those from professional instruments. These observers are not just taking pretty pictures, they are collecting valuable scientific data, or photometry, that can be used to measure brightness changes and map the tail's structure with incredible detail, helping to build a global record of this rare encounter.
The perfect alignment.
As if a volatile comet and a perfectly aimed solar storm weren't enough, the celestial geometry for this event is almost unbelievable. On October 21, 2025, Comet Swan will make its closest approach to Earth, passing just 0.25 astronomical units, or 39 million kilometers away. That's roughly 100 times the distance to the Moon. For a comet with an orbital eccentricity of 0.98 and a low inclination, that's an exceptionally close flyby. This proximity makes it an easier target for even small telescopes. The timing is equally perfect, coinciding with a new moon, meaning the sky will be at its darkest. But there's more. On that same date, a hypothetical interstellar visitor, 3I Atlas, reaches a superior conjunction on the other side of the Sun. As orbital dynamicist Dr. Davide Farnochia from NASA's Jet Propulsion Laboratory would note, the probability of a dynamically new comet like Swan and an interstellar object aligning so closely in time and space is vanishingly small. This alignment provides a unique chance to compare a native solar system body with an interstellar one under the same solar conditions, a rare convergence of a dynamic comet, a potent solar storm, and an ideal observation window from Earth.
Southern skies, spotlight.
For these crucial weeks, the best seats for this cosmic show are in the Southern Hemisphere. From major observatories like the Siding Spring Observatory in Australia, to backyard setups in South Africa and South America, Comet Swan will be high in the sky after sunset. Its path takes it through the southern constellations of Grus and Piscis Austrinus, passing near the bright guide star Fomalhaut. Viewers can use this star as a guidepost to locate the comet, which will appear as a fuzzy star with a long, faint streak extending from it. Even a standard pair of 7x50 binoculars will be enough to reveal the tail, stretching over 2.5 degrees, the width of 5 full moons. For those in the northern hemisphere, the view will improve throughout October as the comet climbs higher in the western sky after midnight. The checklist for observers is simple: find a dark sky, use a star chart to locate the comet, and watch for any changes. By taking images every few minutes, observers can create time lapses that will reveal the tail's motion and any sudden disruptions caused by the solar wind in stunning detail.
Cosmic forces collide.
Here's the bottom line. We have a comet that has just undergone a massive outburst, making it unusually active and producing a large, dense tail. We have a powerful M6.4 flare that launched a CME racing directly towards it at nearly 1,000 kilometers per second. And we have a historically close and well-timed approach to Earth, giving us a perfect view. This sets up a documented encounter between a solar storm and a comet's ion tail, a phenomenon that could cause dramatic changes, with spectral analysis potentially showing Doppler shifts in ion velocities of up to 50 kilometers per second. It's important to be clear, as a scientist from a program like the NASA Comet Observation Database would emphasize, the comet's initial outburst and the solar flare are a coincidence. The sun did not cause the comet to erupt. However, this coincidence has created a rare opportunity for both professional and amateur observers to witness the powerful dynamics of our solar system in real time. The key results are still unfolding, written in gas and light across the night sky. A cosmic experiment for the entire world to watch. We are witnessing a truly unique cosmic alignment. A volatile comet, a powerful solar storm, and a front row seat from Earth. What will happen when the CME slams into Swan's tail is still unknown. Will it be a gentle ripple or a dramatic disconnection that severs the tail completely? The only way to find out is to look up. This is a rare opportunity for anyone with a pair of binoculars or a small telescope to contribute to a global science campaign. The universe is putting on a show, reminding us of the immense and unpredictable forces at play. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching InnoVision Tech.
A decoded transmission from a visitor that has just entered our solar system confirms a chilling reality we've long feared. In the year 2025, NASA officials confirmed that the interstellar object designated 3Y Atlas is not just a passing comet, it is broadcasting a message. What it says could, honestly, redefine humanity's place in the cosmos forever. Let's explore this together. The impossible visitor. What if our third confirmed interstellar guest wasn't just wandering through space but navigating it? When astronomical networks like Pan-STARRS first detected 3Y Atlas in early 2025, it shattered every known classification. Unlike previous interstellar visitors, it was traveling at an unusually high interstellar velocity of 45 kilometers per second relative to our Sun, on a trajectory with a hyperbolic eccentricity of over 3.5. But it was its behavior that was truly impossible. It executed deliberate course corrections, moving with a precision that honestly defied any natural explanation. This wasn't a random rock. Its massive coma, a gas and dust cloud stretching 700,000 kilometers across, pulsed with a steady, repeating electromagnetic signal, unlike the chaotic outgassing of a comet like Hale-Bopp. The trajectory it took was impossibly efficient, using the gravitational wells of planets it passed as if it had a complete map of our system, a feat that takes our own probes years of calculation to achieve. The sheer energy required for these maneuvers, conducted without any visible propellant, suggests a technology that operates outside our known physics. As 3I Atlas carved a path through our asteroid belt with surgical accuracy, it became clear this wasn't an exploration, it felt like an arrival. When physics stopped making sense. There are fundamental laws that govern how objects move in space, but 3I Atlas seems to ignore them. Its trajectory showed a smoothness and efficiency that decades of astronomical observation say is impossible for a natural body. Scientists at NASA began using a term that honestly sent shockwaves through the community-piloted behavior. It executed a course correction amounting to a 15-meter-per-second delta V with no detectable outgassing, a feat that directly violates the Tsiolkovsky rocket equation for an object of its mass. Theoretical physicist Michio Kaku, when presented with the data, noted that the energy required for such a maneuver would be in the terawatt range, equivalent to the entire power output of humanity, sustained for several minutes. To a physicist, this is like watching a multi-ton boulder suddenly levitate and change direction in mid-air. The violation of this fundamental principle sparked frantic debates within institutions like the Jet Propulsion Laboratory, where teams ran millions of simulations and could find no natural model, not even an exotic outgassing of unseen material, to fit the observed data. This wasn't just an anomaly that stretched our theories, it was a direct contradiction of known physical laws. The object that defied reality. When NASA aimed the James Webb Space Telescope at 3Y Atlas, the data it sent back challenged our understanding of reality itself. The thermal readings were the first red flag. Instead of chaotic heat bursts, 3I Atlas showed a consistent thermal signature of 250 Kelvin, pulsing with a precision of microseconds. JWST's principal investigator for the observation, Dr. Jane Rigby, noted that the thermal stability was unnatural. Webb's spectrography then revealed hyper-reflective compounds that appeared artificial, a material with a near-perfect albedo of 0.98, reflecting 98% of all light, something not found in nature. But the most disturbing discovery was a faint electromagnetic pulse repeating every 147.13 seconds. It matched the signature of a real pulsar PSRB 1919+21, yet the object had no magnetic field capable of generating it. It seemed to be mimicking a signal, a form of cosmic camouflage. Webb's infrared analysis also found structural patterns resembling recursive geometric fractals, leading some to float the terrifying consciousness engine theory, comparing it to theoretical concepts like a Matryoshka brain, but on a smaller mobile scale. The combination of these impossible features in one object moves it from unusual to unequivocally artificial. Two visitors, one terrifying pattern. This wasn't the first time we'd been sent a strange message. The mystery of 3I Atlas deepened when researchers cross-referenced its electromagnetic signature with archived data from Oumuamua from 2017. They found the exact same 147-second frequency had been detected briefly in its tail. The difference was the signal strength. Oumuamua's signal was a whisper in the microjanskis barely above the noise floor, while 3I Atlas is broadcasting in the millijanskis, 1,000 times stronger. This really reframed everything. Harvard astronomer Avi Loeb's controversial theory that Oumuamua was an alien solar sail suddenly gained terrifying new ground. the statistical improbability of two interstellar objects separated by 8 years from different star systems, sharing such an unnatural signal is astronomical, suggesting they are part of a coordinated system. Oumuamua's brief weak signal now looks less like a random anomaly, and more like a handshake or ping to test for a response. Now 3I Atlas is answering with a full-blown data stream, implying the test was successful, and our civilization has reached a specific technological threshold. When space objects make calculated decisions. The moment we knew for sure we were being actively monitored was the moment it changed course. Just as scientists believed they had mapped its future trajectory, the Very Large Telescope in Chile recorded a subtle but unmistakable 0.05-degree inclination shift, an adjustment of 180 arc-seconds. This wasn't the random drift of a comet. The object veered off its projected arc, aligning with a new vector that brought it closer to Earth's orbital plane. To mission analysts like planetary scientist Dr. Sarah Seeger, the implication was clear: this was a conscious decision. The maneuver occurred just 72 hours after the James Webb Space Telescope began its focused spectroscopic analysis, a time frame confirmed by NASA's Deep Space Network that rules out coincidence. This inclination shift is an incredibly energy-intensive move, and the action wasn't just responsive, it was almost defiant, a clear message that said, "We see you watching us." The mood at the DSN's Goldstone complex as they tracked this impossible change in real time shifted from academic curiosity to profound alarm. Ancient mathematics from the stars. The signal wasn't just a pulse, it was a message written in the oldest language in the universe. Independent cryptographers analyzing the emissions discovered something extraordinary hidden within the narrow band, 0.1 Hz-wide signal. They found precise mathematical ratios, the golden ratio, Fibonacci sequences, and prime number spirals. This is exactly what scientists like the late Carl Sagan predicted an intelligent signal would contain. The signal wasn't just a simple prime sequence, it was encoding the Riemann zeta function, a deeply complex mathematical concept related to the distribution of prime numbers. Furthermore, the signal's modulation, using a complex form of phase shift keying, corresponded to the value of pi to over 1,000 decimal places, an unmistakable beacon of intelligence. Frank Drake, creator of the famous Drake equation, would have seen this as a direct attempt to communicate not just presence, but profound intelligence. This wasn't a simple hello, it was a comprehensive intelligence test, broadcasted across the solar system for anyone smart enough to listen. Organic chemistry from beyond the stars. It wasn't just a machine, it was carrying the very building blocks of life. James Webb's detailed spectroscopic analysis revealed its outer shell was coated in complex carbon molecules, and its NIRSpec instrument found evidence of adenine, one of the 4 nucleobases in DNA, via clear absorption lines between 260 and 280 nanometers. What was alarming was the purity and organization of these molecules. Unlike the chaotic racemic mixture of amino acids found in the Murchison meteorite, the compounds on 3Y Atlas showed a 99.7% levorotatory excess, a homochiral signature that is a smoking gun for biological or artificial synthesis. Astrobiologist Dr. Heather Graham at NASA's Goddard Space Flight Center found the conclusion both thrilling and, honestly, terrifying. The terrifying implication is that if this is a seed ship, its purpose might not be benevolent. It could be preparing the environment for a subsequent colonization effort. The presence of DNA components suggests a biology that might be eerily compatible, or dangerously competitive, with our own. When Earth responded to the cosmic visitor. We thought we were only observing a distant object, but it was already interacting with our planet. A classified high-altitude surveillance balloon over Antarctica detected an extraordinary event. A powerful 500-megawatt tight-beam microwave burst at 23.4 gigahertz, lasting about 1.2 seconds, originating from the Amundsen-Scott South Pole Station's vicinity. The signal's timing aligned perfectly with another angular shift in 3Y Atlas's trajectory. Moments after the burst, seismic stations recorded ultra-low frequency rumbles, registering a 1.2 on the Richter scale, but resonating at a perfect 0.0068 Hz, the exact inverse of the 147-second pulse. Dr. Francis Halzen, principal investigator of the IceCube Neutrino Observatory, later reported a statistically significant 3 sigma spike in TV-range neutrinos from the same location. The synchronization implies the Earth itself is part of a much larger ancient network that is now being activated, with a dormant relay station buried deep beneath the ice. The asteroid belt death run. Right now, 3I Atlas is navigating a cosmic minefield, and it's doing so with terrifying ease. Its current path takes it directly through the main asteroid belt, traversing the dense Kirkwood gaps at over 60 kilometers per second. Unlike most comets, which have highly inclined orbits, 3Y Atlas is cutting directly through the belt's core. Planetary defense expert Dr. Amy Mainzer, former principal investigator of the NEOWISE survey, noted that its 700,000-kilometer coma is interacting with millions of untracked objects. More astonishingly, minor course corrections have been observed, suggesting it's actively avoiding even meter-sized debris with impossible precision. This avoidance system must be processing the trajectories of over 1.5 million known objects in real time, a feat of computation that dwarfs anything on Earth. Its journey isn't a dangerous run so much as a demonstration of effortless superiority over a hazardous environment, adjusting its path by mere hundreds of kilometers to avoid potential impacts. Rewiring our solar system's neural network. This object isn't just passing by, it may be fundamentally changing the space around us. Data from NASA's Parker Solar Probe, led by scientists like Dr. Noor-e Rawafi, confirms the object is generating alpha waves in the solar wind, disturbances measuring several nanoteslas that can transfer energy over vast distances. Scientists at NOAA's Space Weather Prediction Center are concerned these disturbances could amplify the effects of the next coronal mass ejection, potentially increasing the resulting geomagnetic storm's KP index by 2 to 3 points, pushing it from a moderate to a severe event. The charged dust particles it's shedding are acting as charge carriers, creating a persistent conductive path between the object and the sun's magnetic field lines. It is essentially inserting itself as an active electrical component into our solar system's delicate circuitry. The long-term consequences for planetary magnetospheres, including the one that protects all life on Earth, are completely unknown and deeply concerning. The universe has sent us messengers, and we are only just beginning to learn their language. The mysteries of Oumuamua and other interstellar visitors remind us that we are part of a vast, interconnected cosmos filled with wonders we are yet to discover. The journey into the unknown continues. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the frontiers of science. Thank you for watching InnoVision Tech. What if the next interstellar visitor to our solar system isn't a tiny rock, but an object the size of a city, and it's heading our way? A chilling update on a mysterious object dubbed 3I Atlas has some of the world's top scientists whispering the word artificial. This isn't a comet. It has no tail, it's bigger than Mount Everest, and it's behaving unlike anything we've ever seen. Is this the event that changes human history forever? Let's explore this together.
Comet Atlas Mystery.
Before we get to the terrifying new object, let's talk about the original comet that put the name Atlas on everyone's lips. Here's why it matters. In late 2019, astronomers discovered Comet C 2019 Y4, also named Atlas. It was on a trajectory to become one of the most brilliant comets in decades, potentially reaching a peak magnitude of -5, brighter than the planet Venus. The hype was real, but as it neared its perihelion of just 0.25 astronomical units, about 23 million miles from the Sun in April 2020, it did something completely unexpected. It crumbled. Astronomer Quanji Ye of the University of Maryland, using the Hubble Space Telescope on April 20th and 23rd, watched as the comet disintegrated into a cloud of over 30 distinct icy fragments. Another study by astronomer Michal Drahus concluded the comet's nucleus was spinning so fast, likely with a rotation period under 24 hours, that centrifugal forces simply tore it apart before it could put on its show. This event was a stark lesson for astronomers. It showed that even seemingly powerful comets can be fragile and unpredictable. The mystery of the original Comet Atlas primed the scientific community for weirdness, but it was nothing compared to the new object that would share its name.
The wow signal.
What if this new object, 3I Atlas, isn't sending a message, but is the message? The transcript draws a spooky connection between this new visitor and the single greatest mystery in the search for extraterrestrial intelligence. On August 15, 1977, astronomer Jerry R. Amon was reviewing data from Ohio State University's Big Ear radio telescope when he found a signal so powerful, so clear, that he circled it and wrote, "Wow." The signal lasted for exactly 72 seconds, came from the constellation Sagittarius, and was broadcast at 1,420.4556 MHz. That frequency is sacred in astronomy. It's the natural emission frequency of hydrogen gas, what physicists Philip Morrison and Giuseppe Cocconi called the universal calling card for any communicating civilization back in a seminal 1959 paper. The signal's intensity was over 30 times the background cosmic noise, a massive signal-to-noise ratio. And then, it vanished. In the 45 years since, despite over 100 dedicated searches of that same sky patch by scientists including SETI Institute senior astronomer Seth Shostak, it has never been heard again. It remains a profound cosmic question mark, a potential missed call that makes the arrival of a massive, silent physical object feel like the other shoe is about to drop.
Meet Avi Loeb.
When an object as strange and massive as 3I Atlas appears on the scene, you need a scientist who is not afraid to consider the impossible. Enter Avi Loeb, the former chair of Harvard University's astronomy department and the Frank B. Baird Jr. Professor of Science. Loeb is not a fringe theorist. He's one of the most prolific cosmologists of his generation, having authored or co-authored over 800 scientific papers. He became a household name for his bold stance on our first interstellar visitor, Oumuamua, arguing in his 2021 book Extraterrestrial that the most logical explanation for its bizarre behavior was that it was an alien artifact. He has consistently criticized the scientific mainstream for what he calls a failure of imagination. To back up his words, in July 2021 he co-founded the Galileo Project with entrepreneur Frank Lockien. This is a privately funded, systematic search for physical evidence of alien technology, aiming to get high-resolution data on objects like 3I Atlas. With a 7-mile-wide object now in the mix, Loeb's provocative questions have become more urgent than ever. He forces us to ask, are we so afraid of the answer that we refuse to even consider the possibility of an artificial origin?
Oumuamua discovered.
Before the alarm bells started ringing for 3I/Atlas, there was a dress rehearsal that broke all the rules. On October 19, 2017, Canadian astronomer Robert Warwick, using the Pan-STARRS 1 telescope in Hawaii, spotted a faint object moving so fast and on such a strange path that it had to have come from another star system. It was designated 1I/2017 U1 and given the name Oumuamua. It was our first confirmed interstellar visitor, traveling at a blistering 196,000 miles per hour, 87.3 kilometers per second at its peak. It was on a hyperbolic trajectory with an eccentricity of 1.2, meaning it was moving too fast to be captured by the sun's gravity. Its discovery was a stunning confirmation that objects from other stars wander through our neighborhood. It had already passed its perihelion on September 9, 2017, at a distance of 0.25 AU, and its closest approach to Earth on October 14 was about 0.16 AU, or 15 million miles. The discovery, as noted by NASA scientist Davide Farnocchia, officially opened a new window onto the formation of other solar systems, but it also opened a Pandora's box of questions that we are still struggling with today.
Strange behavior.
Here's where the mystery of interstellar objects truly begins, and it all started with Oumuamua. First, its light curve was bizarre. As it tumbled with a rotational period of about 7.3 hours, its brightness changed by a factor of 10. A team led by astronomer Karen Meach concluded this meant it had an extreme shape, at least 10 times longer than it was wide. But the real smoking gun was its movement. As it flew away from the sun, it accelerated. A team led by Marco Micheli of the European Space Agency confirmed this tiny but statistically undeniable non-gravitational acceleration of about 5 times 10 to the -6 meters per second squared. Comets do this when heated gas shoots from their surface. But the Spitzer Space Telescope, in an observation campaign led by astronomer David Trilling, stared at Oumuamua and saw absolutely nothing. No gas, no dust, no tail, placing an upper limit on dust production at less than a few milligrams per second. It was getting a push from an invisible force. This strange behavior is now being seen in a different way, with 3I/Atlas. While Oumuamua was strange for moving without a visible tail, 3I/Atlas is strange for not having a tail when its immense size says it absolutely should.
Light sail theory.
If Oumuamua wasn't a comet or an asteroid, what was it? This is where Avi Loeb, along with his Harvard colleague Shmuel Bialy, proposed a radical theory in a 2018 paper in the astrophysical journal Letters. They argued that Oumuamua's mysterious acceleration could be perfectly explained by the pressure of sunlight itself. For this to work, the object had to be incredibly thin and lightweight, with a large surface area, essentially a sail built to be pushed by light. They calculated its thickness would need to be less than a millimeter, with a very low area-to-mass ratio. Its density would have to be around 0.1 grams per cubic centimeter, far less than that of a typical icy comet, 0.6 grams per cubic centimeter, or rocky asteroid, which is over 2 grams per cubic centimeter. This light sail is a technology that humans are actively developing for interstellar travel, most notably through the Breakthrough Starshot Initiative, for which Loeb chairs the advisory board. The stunning implication of their theory is that a light sail cannot be natural, it must be engineered. It established a critical intellectual framework. When faced with an object that defies all natural explanations, an artificial origin must be considered a scientific possibility.
Universe age debate.
The arrival of something as seemingly impossible as 3I/Atlas is made more plausible by a simple fact: our entire understanding of the cosmos is currently being rewritten. For decades, the age of the universe was confidently stated as 13.8 billion years. But, the James Webb Space Telescope is now sending back data that challenges this fundamental number. Astronomers like Rohan Naidu of the Harvard-Smithsonian Center for Astrophysics have used the JWST to identify surprisingly mature and massive galaxies at a redshift of 13. This means we are seeing them as they were just 330 million years after the Big Bang, far too developed to fit our current models. This data, some from the Cosmic Evolution Early Release Science or SEERS survey, has led some physicists, like Rajendra Gupta of the University of Ottawa, to propose the radical idea that the universe could be as old as 26.7 billion years. This ongoing debate, fueled by JWST's principal investigator for extragalactic deep surveys, Stephen Finkelstein, reveals a crucial truth: our cosmic knowledge is still in its infancy. If our most basic timeline of the universe could be wrong, then our assumptions about what is possible within it are also on shaky ground.
NASA spy agency.
If a 7-mile-wide object of unknown origin were on a path through our solar system, who would be in charge of the response? While we think of NASA as an agency of peaceful exploration, a 2020 executive order quietly reclassified some of its functions to include intelligence, counterintelligence, investigative or national security work. And, while NASA Watch editor Keith Cowing noted this was largely a bureaucratic move related to federal labor laws, it highlights a deep, underlying reality. NASA has long collaborated with the Department of Defense and the National Reconnaissance Office, or NRO, which actually gifted NASA 2 Hubble-class spy telescopes, each with a 2.4-meter primary mirror, back in 2012. This collaboration, often managed by former NASA administrators like Charles Bolden, means that in a first contact scenario, NASA's assets, from its worldwide deep space network to its fleet of planetary probes, would instantly become the front line of global intelligence gathering. The line between pure science and national security would just evaporate. That quiet reclassification is a reminder the government's plan for contingencies we aren't told about, and when faced with a visitor like 3I/Atlas, NASA's mission could shift from exploration to defense overnight.
Interstellar visitors.
For centuries, we thought our solar system was an isolated island, but now we know it's more like a busy port of call. The discovery of Oumuamua in 2017 was the first confirmation. Then, just 2 years later in 2019, amateur astronomer Gennady Borisov discovered a second interstellar visitor, 2I Borisov. But Borisov was different. It looked and acted exactly like a normal comet, with a visible gas and dust tail and a nucleus estimated to be about 1 kilometer in diameter. This discovery was crucial. It showed that other star systems produce normal comets just like ours, which only made Oumuamua's weirdness stand out even more. Now, with the potential discovery of 3I Atlas, we're entering a new era. The Vera C. Rubin Observatory, once fully operational, is predicted by its director Jelko Ivezic to find dozens of these interstellar objects every year. Yale astronomer Gregory Laughlin has calculated that trillions of such objects are likely roaming our galaxy. Most will be rocks, but if even a tiny fraction of 1% are probes, our solar system could be getting visitors on a regular basis. We just never had the technology to see them until now.
Humanity and war.
The appearance of a colossal object like 3I Atlas forces humanity to look in the mirror, and honestly, the reflection is not flattering. How would we react? This question brings us to the Fermi paradox and the chilling concept of the Great Filter. The paradox asks why, given the probability, we haven't found any other civilizations. One of the most terrifying answers is that civilizations destroy themselves before they achieve interstellar status. This self-destruction is known as the Great Filter, a term coined by economist Robin Hanson in 1996. Carl Sagan often discussed how a civilization's technological mastery of weapons could be the self-imposed limit. This is explicitly quantified in the Drake equation formulated by astronomer Frank Drake in 1961. One of its key variables is L, the lifetime of a communicative civilization with a current global arsenal of roughly 12,500 nuclear weapons. The value of L for humanity remains terrifyingly uncertain. The idea that a civilization can transcend its tribalism is the ultimate leap of faith. 3I Atlas isn't just a test of our science, it's a test of our maturity as a species. From a 7-mile-wide silent anomaly to the bizarre precedent set by Oumuamua, the evidence is mounting that we're entering a new era of astronomy, one where we must be prepared for anything. The object known as 3I Atlas represents the greatest question ever asked: are we alone? Whether it proves to be a natural wonder or something far stranger, its presence in our solar system is a humbling and, yeah, perhaps even a terrifying reminder of just how much we have left to learn about our place in the universe. The mystery is just beginning, and the next piece of data could change everything we know about our reality. What do you think 3I Atlas could be? Let us know your theories in the comments below. Don't forget to like, subscribe, and hit the bell icon for more explorations into the final frontier. Thanks for watching InnoVision Tech.